All right, we got the 2.6 notes factoring the sum and difference of cubes. Now, before we get to the cube stuff, let's look at something that we learned last year. If I have something in the form a squared minus b squared, how does that factor? Okay, so hopefully you can fill this in from memory. But if we have something in the form a squared minus b squared, it's going to factor to a plus b times a minus b. Okay, now again, hopefully you remember this. This is difference of two squares. We've actually used it this year a bit already. Okay, now, how do we know the answer to this is that? Well, basically because we memorized it, right? It's a formula. We can prove that it works. We can maybe even try to figure out why it works, all that stuff. But the point is, we know when something's in this form, it factors like this. Okay, we've shown that it works. Now we can just use it. Well, kind of similarly here, when we're dealing with the difference or sum of cubes. So if I have a cubed minus b cubed, or a cubed plus b cubed, this only works when it's a minus sign, but for cubes it works for positive and negative here. But when it's in this form, it's going to factor like this. Okay, now don't worry too much about why it works. We'll show that it does work, but this is the formula. Okay, so if I have something in the form a cubed plus b cubed, it's going to factor to a plus b times a squared minus a times b plus b squared. Okay, a cubed minus b cubed, well, there's the formula. It's very similar. Okay, now like it says here, if you can remember SOAP, it helps with cubes. So SOAP is kind of like an acronym. It helps us remember what signs go where. If I have a cubed plus b cubed, okay, well, my signs are going to be positive, negative, positive. In other words, the S stands for the same as that sign, O stands for the opposite of that sign, and then the last sign is always positive. So same, opposite, always positive, relating to that sign there. So if it's negative, well, then it's same, opposite, always positive, so the first two switch. Okay, so again, SOAP will help us remember what the signs are going to be. Okay, and then there's another little trick to fill out the rest of the parts. We'll get to that on example number 1. So let's take a look at example number 1. Okay, so example 1, we have x cubed plus 8. Now, one hint that this might be a cube factoring problem is that there's only two terms. If there's two terms, it might be difference of squares, might be difference of cubes or sum of cubes, or maybe just a GCF, or maybe a combination of those. Okay, so here, what form is this in? Well, obviously this is a perfect cube, it's x cubed, so that's a giveaway, that's probably a cube factoring problem. Plus, and then 8, well, I can think of 8 as 2 cubed. Okay, now we don't always have to write 2 cubed, we just need to know that 2 is the number that's being cubed there. Okay, so now we know it's definitely a cube factoring problem, so how do we factor this thing? Well, what's our answer going to look like? Well, it's going to be a binomial times a trinomial. So draw your two blank sets of parentheses. The second one needs to be bigger because there's 3 parts in there. Okay, let's use SOAP to figure out our signs. So it's going to be the same as that first, so positive, then the opposite of that, and then always positive. So plus minus plus for this one. And then next, what are the two things being cubed? In other words, if this is a cubed and this is b cubed, what's a and b? Now sometimes, we already wrote the x and the 2 here, but you can even put a little note to yourself, well, it's x's and 2's that I need to plug into my formula, because you'll notice it's just all a's and b's in here. Okay, so just basically drop these things down into the first binomial, x and 2, and then next, to figure out what goes here, here, and here. We're going to do a little bit of the electric slide with our fingers. The electric slide is where you just kind of pace back and forth like that. Okay, so we're going to start here. So I want 2 of each because I got 2 fingers on that x. So I want 2 of those, which is x squared. And then slide over 1 of each, x times 2, which is 2x. And then 2 of those, 2 squared, which is 4. So again, it's 2 of those, 1 of each, 2 of those. Okay, so start on the left and do the little electric slide. So again, 2 of the x's and 1 of each, and then 2 of those. So that's going to be our little trick to filling in the trinomial there. Okay, and then we're done. Okay, and there's never anything else you're going to have to do after that, because if there was, we'd have a different formula. Okay, sometimes this trinomial might look like it's factorable, but as long as we did this correctly, it won't be. Okay, so again, we are done. Now, we're only going to do this on this first problem, but how do we know that this thing works? Well, let's multiply our answer back out and then see if we get what we started with. Okay, now again, we're only going to do this once, but let's make sure it works. X times x squared is x to the third. X times negative 2x is negative 2x squared. X times positive 4 is positive 4x. Okay, so we distributed the x to these three terms. Now I want to distribute the 2 to these three terms. 2 times x squared is positive 2x squared. 2 times negative 2x is negative 4x. And then 2 times positive 4 is positive 8. And then when we combine like terms, let's see, so this is the only x cubed term, so we get x cubed. And then negative 2x squared plus 2x squared, well, those cancel. Positive 4x minus 4x, those cancel. And then I get plus 8. Is x squared plus 8 what we started with? I'm sorry, x cubed. I said it right and wrote it wrong. Is x cubed plus 8 what we started with? Yeah, it is. So we can see that this formula worked, and it'll work every time. We don't need to check the rest of our answers. Okay? All right. Next problem. So again, the first thing we got to do is recognize what type of problem this is. Is it a difference of squares? Well, no, because it's plus. Is it cube factoring? Yeah, the x cubed, again, kind of gives that away. Okay, so then we have another cube factoring problem here. What is the cube root of 27x cubed? In other words, what's my a going to be that I'm going to plug in? Well, the cube root of 27 is 3. The cube root of x cubed is x. So then we're going to be dealing with 3 x's. And what's the cube root of 1? 1. So this is my a in my formula. This is going to be my b. Okay? All right, and then how do we factor this thing? Well, I know it's going to look like this, a binomial times a trinomial. Okay, so we're going to draw our parentheses there. Let's do our signs first. So we want to use SOAP. So it's going to be the same as that, the opposite of positive, and then always positive. So again, same, opposite, always positive for the signs. And then next, just drop these things in here. So we get 3x plus 1. And then we want to use the electric slide. So I want 2 of these, then 1 of each, then 2 of those. So first, 2 of these. 3x times 3x is going to be 9x squared. And then 1 of each would be 3x times 1, so that's just 3x. And the next 2 of those, so 1 squared is just going to be 1. And then we're done. Okay, so the formula is not easy to remember, but once you get that formula down, these actually aren't very hard to do. All right, moving on. Example 2, factor completely. So again, only 2 terms. This is a perfect square, so is it a difference of 2 squares? Well, no, because x cubed is not a perfect square. Is it a cube factoring problem? Yeah, now 64 is a tricky number because 64 is a perfect square, but it's also a perfect cube. The cube root of 64 is 4. Okay? And then the cube root of x, so what times itself 3 times equals x cubed is x. What times itself 3 times equals y to the 6th, or y squared. So then xy squared is my a, and 4 is my b. Okay? And then now we can factor this thing. So it's going to be a binomial times a trinomial. So we draw our parentheses. And then we want to use SOAP, starting with negative. So we got negative, positive, and then positive. So same, opposite, always positive. Okay? I know we got to drop these things in here. So xy squared minus 4. And then I want 2 of these. So xy squared times xy squared is going to be x squared y to the 4th. And then 1 of each is going to be 4xy squared. And then 2 of those, 4 squared is 16. And then we're done. Okay? All right, a little trick when you're dealing with variables that have higher exponents. Basically just divide the exponent by 3 to see what your new exponent is going to be. Okay? All right, next one. Negative x cubed minus 8. Okay, now I want to change one thing here. If we factor out a negative, we can do that. Yeah, let's do that. Let's take out the negative, and that leaves me with x cubed plus 8. And then instead of 8, let's go ahead and write it as 2 cubed so we know what our a and our b are. Okay? So this one, we just took out a GCF first of negative 1, which we don't need to write the 1, just the negative is fine. Okay? And then when I factor this thing, it's going to be a binomial times a trinomial. And then don't forget, we already took the negative on the outside, so then that has to stay on the outside. And then we want to use SOAP. So again, once we took out the negative, it became a positive. So then the same as that, the opposite of that, and then always positive. Okay, now we got our signs in there. And then let's see, I got to drop an x and a 2 down here. And then I want 2 of these here, so x squared, then 1 of each here, so 2x, and then 2 of those gives me a 4. And again, now we're done. Okay, and again, this thing's going to look maybe like it's factorable once in a while, but it won't be. Okay, all right, moving right along. Next one, kind of similar to the last one. Is this a difference of cubes problem or a sum of cubes problem? Well, no, because these aren't perfect cubes. They're also not perfect squares. Okay, so then what do we do here? Well, the first thing we should always check for, kind of like we did in the last problem, is we want to look for a GCF. So do these two terms have anything in common? Yeah, these are both divisible by 2, so we can take out a 2. And then x to the fourth and x to the first, well, they each have at least one x, so we can take out an x. So if we take out a 2 and an x, which is kind of like dividing by a 2 and an x, what are we left with? Oh, 125, x to the third, plus, and then the x is gone completely, and then half of 128 is 64. Okay? And we might be done factoring, but now we got to check. Is it a cube factoring problem now? Well, sure, that's a perfect cube. That's just 5 cubed. That's a perfect cube, and then that's 4 cubed. So yeah, we already took out a GCF, but now we can factor it again. Our A is going to be 5x. Our B is going to be 4. Okay? So then we can factor this. It's going to be a binomial times a trinomial. And don't forget, we already took out that 2x, so that has to stay on the outside. Okay? Using SOAP, our signs are going to be plus, minus, plus. Okay, so same, opposite, always positive. And then we got to drop these things in here. So we got 5x plus 4. And then I want 2 of those, so 2 of the 5x's. So 5x times 5x, 25x squared. Then 1 of each, 4 times 5x is 20x. So 2 of those, 1 of each, and 2 of those, 4 squared gives me 16. Okay, and then we're done. Okay, and don't dwell on this. Well, can we factor it? Maybe if I try. No, it's not going to work, so don't waste your time. We're done. Okay. All right. The only time that this or this might be factorable is if we don't take out a GCF first. Okay, because it's possible for something to be, like sum of 2 cubes, but still have a GCF we could take out. Okay, so whether we take out the GCF in the beginning or the end, it's going to factor the same thing. It's always going to be easier to take out that GCF first. All right, last one, 343x cubed plus 64y cubed. Okay, now 343 is not a perfect cube we deal with a lot, but it is a perfect cube. 343 is 7 times 7 times 7. So then my A is going to be 7x. My B, 64, that's one that's come up a few times. Again, it's a perfect square and a perfect cube, but it's going to be 4y. Okay, so this is my A and my B, and now we're ready to factor this thing. Okay, now it's going to be a binomial times a trinomial. And then my signs are going to be the same as that, the opposite of that, and then always positive. Okay, and then next let's fill these in. So we know we got 7x plus 4y in our binomial. And then I want 2 of those, 1 of each, then 2 of those. So 2 of those is going to be 49x squared. 1 of each is going to be 28xy. And then 2 of those, 16y squared. Okay? And make your parentheses as big as you can, as much space as you have. We don't want to have to jam it in there. Okay? So there is our first page. Let's just go right along to the second page. Keep this to one video today. All right. On the back, got to fill in a blank here. So it says a blank of a polynomial function is the solution to f of x equals 0. So there's different things we can call the solution. We can call it our solution, our answer. Last year we called them roots sometimes. Another common one that you're going to see is a 0. So we're going to put 0 / root / we can even put answer. Okay, but again, 0 is the one that they're really referring to for this particular problem. Okay, so you're going to see find the zeros. Well, that just means set your equation equal to 0 and solve, like we've been doing. Okay, so just a different name for the answer. Okay, but a 0 or root or answer of a polynomial function is the solution to f of x equals 0. So again, we set our function equal to 0. For each function, write in factored form, then determine the real and imaginary zeros. Okay, now whenever we factor one of these problems, let's take a look at like our last one, for example. Our binomial, usually if it doesn't have y in it, this is a little funky. But if it's just something with x in it, our real answers are going to come from the binomial. Our imaginary solutions are going to come from this trinomial. So let's look at how to do that. All right, so example 4, our function is x cubed minus 8. Okay, well, we basically want to set that equal to 0 and then solve. So if we have x cubed minus 8 equals 0, how can we solve that thing? Okay, now sometimes you might be able to think of the answer, what cubed minus 8 is 0? Well, I know one of my answers is going to be 2, okay? But we're always going to have as many answers as our highest power of x. So since this is a cube problem, we're going to have 3 answers. So great, we thought of one, but we're missing 2. So we can't just do it in our head, we got to work it out. All right, so to solve this thing, we want to solve by factoring. So I know how to factor this thing. It's going to be a difference of cubes. So it's going to be a binomial times a trinomial, and that thing's set equal to 0. My signs are going to be the same as that, opposite of that, and then always positive. I know this is x cubed, this is 2 cubed, so it's going to be x and 2 in here. And then I want 2 of the first thing, 1 of each, and then 2 of the second thing. All right, so now I've got it factored. Okay, well, if I've got this thing times this thing equals 0, I know that one of these things has to equal 0. So then I want to see, when do my factors equal 0? This one's easy. We can probably do that in our head. When does x minus 2 equal 0? Well, when x equals 2. Okay? But then when does this thing equal 0? So then we want to look at that by itself. So let's rewrite that. I want to know, when does x squared plus 2x plus 4 equal 0? Okay? Now, we already know it's not factorable. We talked about that. I mean, you can try, but it doesn't work. So then probably the best method would be use the quadratic formula. Okay, so then that's going to be negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. All right, and then we just got to simplify that. So we get negative 2 plus or minus the square root of 4 minus 4 times 1 times 4 is 16. 4 minus 16, we get negative 12 over 2. Okay. Next, let's keep going down. We got a little bit more space there. We get negative 2 plus or minus. Now, since it's negative, I can take out an I, and then the square root of 12, we can simplify to 2 root 3. So that's going to be 2I root 3 over 2, which I don't want to go down any further. We're getting in the way of this next problem. We can do our last step to the right here. We just want to reduce everything, divide everything by 2, and we get negative 1 plus or minus I root 3 over 1, which we don't need to write. So then these are our 2 imaginary solutions. Okay? If we want to put them all together, we can finish it off over here. We had x equals 2, comma, our other 2 answers are negative 1 plus or minus I root 3. So negative 1 plus I root 3 and negative 1 minus I root 3 are our other 2 answers. So there are our 3 solutions. So like I said, you're going to get a real solution from the binomial, 2 imaginary solutions from the trinomial. Okay. Also, something to keep in mind that might help you simplify the radical, because 12 wasn't hard, but the numbers get bigger. And I'm not sure why this happens, but we're always left with root 3 for some reason, which means this number is always going to be 3 times a perfect square. So basically just divide by 3, figure out what that perfect square is. It'll help you simplify this radical. Okay? All right, 2 more to go. Here, we want to solve this thing. So first of all, like it says, we want to set it equal to 0. So then let's do 24x plus 81x to the 4th equals 0. All right. Let's start by factoring this thing. We can take out a GCF. That's what we want to do first. And again, that's what you should always check for first is a GCF. And we're probably going to need space, so I'm going to separate the first problem from the second. Okay, so we can take out a GCF of 3. So if I pull out a 3 and an x, because they both have an x there, and then that leaves me with 8 plus 27x to the 3rd. Also, keep in mind, in our original problem, since our highest power of x was x to the fourth, on this problem we're going to get 4 answers. Okay? All right, so how do I factor this thing now? Well, now it is a sum of cubes. So don't forget, we already got the 3x on the outside, and then it's going to be that times a binomial times a trinomial, and then we want to set that equal to 0. Okay? That is 2 cubed, so I know it's going to be 2 plus, and that the cube root of 27 is 3, the cube root of x cubed is x, so 3x. So in other words, my a value is 2, my b value is 3x. Okay? Let's finish the signs. Same, opposite, always positive. Okay? And then we want 2 of those, so 2 squared is 4. 1 of each, multiply them together to get 6x, and then 2 of those, 3x squared is 9x squared. Okay, so now we've got it factored. Okay, now, why is this going to give us 4 answers? Well, we get 2 imaginary solutions from that, 1 real solution from that, and then we've got another factor, which is going to give us our 4th real solution. Okay, so what are our answers going to be? Let's do it in black so they kind of stand out. X equals, well, when does 3x equal 0? Well, when x equals 0. When does 2 plus 3x equal 0? Now, it might be easier if you rearrange them 3x plus 2. And when you solve that, you're going to get negative 2/3. Okay, you can write it off to the side and solve it if you want to, but that's going to be the answer. And then when does this thing equal 0? Okay, that's what we need to solve. That one I cannot do in my head. So when we rewrite this, though, I'm going to switch the order because I want it in descending order. I want my biggest power of x first, and then, so basically backwards. So we want to know, when does 9x squared minus 6x plus 4 equals 0. Now I've got my a, my b, and my c, and I can plug those into the quadratic formula. Okay, so we get negative b, which is going to be positive 6, plus or minus the square root of b squared, minus 4 times a times c, over 2 times a. Okay, so this one has some bigger numbers, so a small calculator might be helpful. Okay, so we get 6 plus or minus the square root of, let me show my work here. So let's see, we get 36 minus 16 times 9. It's going to be 144 over 18. Let's simplify that. So we get 6 plus or minus the square root of, and then 36 minus 144. So let's see, it's going to be negative 108 over 18. We're probably going to need the space. Oops, sorry about that. We're probably going to need the space. We're going to squeeze it in up here as best we can. So that's going to be 6 plus or minus, let's see, 108. So again, it's always going to be 3 times a perfect square. 108 is 3 times 36, and 36 is a perfect square. You can take out a 6 and an I since it's negative, and we're left with 3. Again, if you need to work that out off to the side, you can, but that's going to be our answer. I'm just trying to go somewhat fast so we don't make the videos too long here. 18. And I want to reduce. 6 goes into all 3 of these numbers. 6 goes into here 1 time, goes into there 1 time, goes into there 3 times. So finally, we're left with 1 plus or minus I root 3 over 3. Okay, so this part can be a little tedious, but we got our 2 imaginary solutions. So we can add that to our list over here. Comma 1 plus or minus I root 3 over 3. Okay, so here our 4 answers are 0, negative 2/3, and then here are our 2 imaginary solutions. All right, last one. Okay, we want to solve 27x cubed plus 1 equals 0. This one shouldn't be as bad. Okay. First of all, our a is going to be 3x, our b is going to be 1. Okay, so let's rewrite the problem first. 27x cubed plus 1 equals 0. I want to factor this thing. Let's do this one kind of quickly. This is going to be plus minus plus 3x 1, 9x squared, 3x, 1. Okay, so we got it factored, set equal to 0. So then if this thing times this thing equals 0, I know that at least one of these has to be 0. Okay, this 3x plus 1 is going to equal 0 when x is negative 1/3. And then I want to get my two imaginary solutions from that last part. We're going to need to kind of maximize our space here because we came low on the other one. But I want to know, when does 9x squared minus 3x plus 1 equal 0? Okay, so we want to use the quadratic formula. So it's going to be negative b, which is going to be positive 3, plus or minus the square root of b squared minus 4 times a times c over 2a. Okay, so we're going to get 3 plus or minus the square root of, let's see, 4 times 9 is 36. 9 minus 36, brain fart, just making sure, is negative 27. Check one thing for AC. Sorry about this, guys. I want to make sure I didn't make a mistake. Okay. All right. Sorry, I'm just doubting myself here. So we get 3 plus or minus the cube root of 27. Oh, I'm sorry, square root. That's why I was thinking it's the cube root, and I was worried I was going to have to take the cube root of that, not the square root. So that I did it right. Okay, so let's see. 27 we can think of as 3 times 9. 9 is a perfect square. We can take out a 3 and an I since it's negative, and we're left over with the 3 in there over 18. I was getting my cube roots and my square roots mixed up. Sorry for the delay there. We divide everything by 3. I get 6 here, 1 there, 1 there. So our final answer is 1 plus or minus I root 3 over 6. And then that is going to give us our two imaginary solutions. Let's add those to our list over here. 1 plus or minus I root 3 over 6. And those are our 3 answers for the last problem. Sorry, we stumbled through that one. Quick reminder, when you're dividing everything by 3, the 3 doesn't disappear, it becomes a 1, as it has on a couple other problems. A common mistake I see is people just ignore that completely and just put plus or minus I root 3. Make sure you have the 1 there. All right, that wraps up the notes.